Welcome back. Hopefully you had a chance to watch the intro video, which goes over some key definitions of serverless, like workers, endpoints, and handlers. So today, this is what we'll be discussing. Setting up an endpoint, creating an API key, downloading a pre-existing image, and sending off a request. The runpod community has a wide variety of serverless images that they built to work for the service. So if you find something out there, no need to reinvent the wheel. You can just drop it right in here with the same flow. But for this example, we'll be using the simplest of simple. Just an endpoint that responds with a hello world no matter what you send to it. We won't get into any code or image building yet, only using ready-made stuff. But don't worry, that's coming in a future video. As we described it, serverless is a solution for anyone tired of paying for GPU time that they're not actually using. So here's a quick recap of what we discussed. The basic flow is that you send a platform an API request. The endpoint delegates the task to any available active workers. If none are available, then the endpoint spawns a flex worker to accept the task instead, up to the maximum number of flex workers defined in the endpoint. The handler executes the task and returns a result, and then the worker goes back to idle if it's active, or shuts down if it's flex, and there are no further requests to work on. So the first prerequisite is setting up an API key. This identifies your request as belonging to you, so it can be assigned to your endpoint, and then the request can be deducted from your balance. So it's security as much as it's identification. So we can set up an API key by going to Settings, and then API Keys. And let's create a new key. And let's just give it a name. And let's take a look at the privileges. So an unrestricted API key is very powerful, and if it's leaked, it can be used by bad actors to create pods or endpoints on your account. So let's follow good security hygiene here and follow the principle of least access. Let's leave GraphQL at none, and then read write for API.runpod. If you want, you can come back after the endpoint's created and even get more granular and assign specific API keys to specific endpoints. But this will do for now. Now, let's go set up our endpoint. I've already pre-built and uploaded a Docker image to Docker Hub. But if you'd like to see the code in GitHub, I put it into the description. What this code does is simple. It ignores whatever you tell it and simply gives a hello world back. But at this stage in the game, that's fine. It's more important to show the process for sending and receiving requests to endpoints. Don't worry about the specifics of coding for now, but I've got a great example coming up in our next video for image and video captioning that's going to blow your mind. All right, to start, we're just going to go to Serverless, New Endpoint, Docker Image. Go ahead and paste in our Docker image path. And we'll just give it a name. And we'll just select 16 gigs to start. Then scroll down, hit Create Endpoint. And it will take just a few seconds to download the Docker image from Docker Hub. Once you see this go from initializing to ready, then you're good to go. All right, to send a test request, we're just going to go to our Request tab right here and run a request. Because this is a very simple request that hasn't yet involved a GPU, it'll only take less than a second to get a response. So the Request tab is great for checking to see whether your endpoint is running, but it's not really using the platform to its fullest. Now, to send an API request through curl or something similar, we're going to need two things. The API key we generated earlier, along with your endpoint ID. The endpoint ID is automatically generated, can be found under Overview, and then scrolling down to Endpoint ID. All right, to create an API request, we're going to use the following format, which is available for copy and paste from the Overview page. This will include everything you need to send a request to the endpoint. The only thing you need to do is put in your API key. I will use mine, and while I am showing it on screen, don't worry, it'll be deactivated by the time the video's up. So we will just copy and paste and send this right in. Since I am on Mac OS, we're going to use a terminal for this. And you can pull the status of the request with a status command. All you need to do is just copy and paste your ID here. And then paste it into the command here. Just paste here. And you can see we got a request back. What this will do is it will show you the payload along with the runtime and some other parameters for the job. And you can even send payloads of any type in this through binary data by just encoding as base64. But for now, this will just demonstrate how it works. On the other hand, if you would like to create the connection and keep it open until a response is received, you can use run sync rather than run. Let me just paste this in. What it will do is it will keep that connection open until you get a response back. What's most important to know is that this request only costs you a fraction of a cent on a 16 gig GPU. 1/100th of a cent to be exact. So you can run this request 100 times in serverless and only pay a single cent. In comparison, a comparable GPU spec in pod form would cost 32 cents per hour. And due to the boot up time involved, you would spend a few cents before you got any useful work done, because you would need to start your pod, wait for it to download an image, log into the pod, clone your repo, download any necessary models, and so on. When you're running operations with high-end hardware like multiple H100s, you can see how this would not be tenable, because cents on a 16 gig would become entire dollars wasted on a higher end. So there you have it. You've just created your first runpod serverless endpoint and sent a request. So let's quickly recap what we've accomplished today. We set up a secure API key following best practices, create a serverless endpoint with a pre-built Docker image, tested it through the UI, and then sent proper API requests using curl. We've seen both async and sync request methods, and most importantly, we've demonstrated how cost-effective this approach is. Remember, what we've done today is just scratching the surface. This simple hello world demonstrates a workflow, but the real power comes when you start applying the same pattern to AI workloads like image gen, video processing, or language models, all the while just paying for the exact compute time you need. So we're really excited to see what you come up with, and we're happy to join you on this journey. Just wait for our next videos, and you'll start seeing some more advanced stuff pretty soon. Till then, be well.